All right, so now hopefully you've thought about this problem where we're dropping a ball off the Empire State Building. The Empire State Building is 1,250 feet tall exactly. We're assuming gravity is 32 feet per second, and we want to know at what speed does the ball hit the ground. And so what we did in the last video is we talked about some ways that we could think about what are the initial values that we have: the initial velocity, the initial position, what's our acceleration, and we reasoned that the acceleration was negative 32. It was negative because the velocity and the acceleration have the same sign because the ball's speeding up. As the ball falls, it's speeding up. And so that tells you that the velocity and the acceleration are acting in the same direction. They have the same sign. And the velocity is negative because the height is decreasing. So all the stuff that we know about calculus still stands, of course. The velocity being the derivative of the position. If the position is decreasing, the velocity is negative. Okay, so that is basically what we decided in the last video. And so if we go from here, we can actually just figure out what are the equations that we have. And so if a of t is 32, that tells us that the velocity is going to be negative 32t plus the initial velocity, which is 0, so just negative 32t. And therefore, the position is going to be negative 16t squared plus our initial position, which was 1250. By the way, one thing that I did in this example, and I apologize, is that we're studying motion along a line, and we're assuming that there's no air resistance. Air resistance, it turns out, is kind of a pain to model, but we will do that soon. We just need a little bit of background in differential equations first. So differential equations lets us take this really oversimplified model and it makes it a little bit more realistic at the cost of being a little bit more complex mathematically. So we'll talk about that soon. And so here's our position function, our velocity function, and our acceleration. And I should mention that this is in feet. The velocity is in feet per second, and the acceleration is in feet per second squared, or feet per second per second. All right. And then what we want to do is we want to know at what speed does the ball hit the ground. And so the first thing that we have to do is we have to figure out at what time does the ball hit the ground. And so we're going to solve s of t equals 0. And to do that, what that means is that 16t squared is going to be 1250. So that t squared is going to be 1250 over 16. And here's where we'll need a calculator. That means that the time is going to be, I did this ahead of time, but the time is going to be 8.839 seconds. 8.839 seconds. Okay, and so after 8.839 seconds, the ball hits the ground. And then what we wanted to do is we wanted to figure out what's the speed of the ball at that point. And so the speed of the ball, first we have to compute the velocity. And to get the speed, let me just write it this way. So the speed of the ball as it hits the ground is going to be the absolute value of v of 8.839. Okay, maybe I know that the velocity is going to be negative, so we have to take the absolute value of that to make sure that we have a positive value for the speed. And so v of 8.839, if we take 8.839 and plug it in here, what we end up with is 282.848. Okay, and this is, the speed is also measured in feet per second. Okay, so this is 282.848 feet per second.